Hello students, welcome to the chapter working with functions, and this is the part 8 of this particular chapter. I hope you have watched the previous parts of this series. If not, you can always check out. I've given all the links in the description. So today's topic of discussion will be mutable and immutable properties of data objects. So from class 11 concepts, you already know what mutable and immutable is. Mutable means such data objects whose values can be changed after declaration are known as mutable, and those data objects whose values cannot be changed after declaration are known as immutable types. So examples of mutable are list, dictionaries, and examples of immutables are int, float, tuples, and some more. So here in this part we are basically going to discuss about how a function will behave if we pass a mutable object and how a function will behave if we pass an immutable data object. So let's begin with the immutable data objects. So passing immutable data. So remember this point, if a variable is referring to an immutable type, any change in its value will also change the memory address it is referring to. So if we are passing an immutable type like integers through a functions, then if any change in value occurs within the function definition, then it will also change the memory address. And what will happen if the memory address changes? If the memory address changes, then the changes will not be reflected back to the main functions. It will be clear when we discuss it with the help of a code. So passing immutable data, let us consider this code. I'll explain this code here. So the code for understanding passing immutable type value to a function. So I've discussed a code here. So here we have 11 lines. So from lines 2 to 7, this is the function definition, and from line 8 to 11 it is the main function. So here at first what will come? N equals to 3 will come. So n equals to 3. So therefore the value stored in the variable n will be how much? It is 3. It will have a memory address. Let's say the memory address of n is, let's say, 100. Okay. After that, what will be displayed? Calling function test immutable by passing n with value. So if this is the output screen, the first line of the output screen will be this one, calling function test immutable by passing n with value. And what is the value of n? The value of n is 3. After that, the 10th line will run where the function calling is happening. What is the name of the function? The name of the function is test immutable, and we have sent an immutable type value through it. What is the immutable type? It is an integer. And what is the value of n? 3. So 3 will be copied to what? 3 will be copied to a. So now what will be stored in a? A will also take the value of 3. Okay, but since it is an immutable type, the memory address of a will not be 100. It will be something else. Let's say it is 200. So what will be the next line of output? Inside test immutable. So next line of output will be inside test immutable. What will be the next line? Value received in a as, so value received in a as a. What is the value stored in a? The value stored in a is 3. So we'll get the output as 3. After that, what is happening here? A equals to a plus 2. So a equals to a plus 2 means what is the value of a now? 3. 3 plus 2 is 5. So this 3 will be replaced by 5. So now a is pointing towards 5. That means the value of a now is how much? It is 5. After that, what will be what will be displayed in the next line? Value of a now changes to this line. How much? 5. After that, what will be printed? Returning from test immutable. I am writing here returning from test immutable. And after that, the control will be transferred to line number 11. Why line number 11 and not 10? Because there is no return type. I have already discussed how programs can be traced in one of the parts of this particular chapter. Now, after returning to line number 11, what will be printed? Back from test immutable, value of n is n. So what is the value of n? The value of n is 3. So the value of n will not be displayed as 5. The value of n will be displayed as 3 because the memory address, so this 100 is not the value, this 100 is the memory address. The memory address of n is 100, but the memory address of a is 200. What we are displaying, n or a? We are displaying n. So since we are displaying n, therefore we will get the answer as how much? We will get the answer as 3 and not 5. So what we can say, if a function is referring to an immutable data type, then whatever changes we do inside the function definition, those will not be carried to the main function. It will be carried if we use the return statement, but if we do not use the return statement, then it will not be carried to the main function. So this will be our output when we run the program. Okay, so at first the value is 3, after that inside test immutable, these are inside the function definition, then value was 3, I have displayed it, then we have modified the value of a to 5, then after that returning from test immutable, and finally when we displayed the value of n, it is displayed as how much? It is displayed as 3. Why it is displayed as 3? It is because the memory address of n and the memory address of a both are different. Okay, so let's run and see this particular program. So this is our program. So if we run it, you will get this as the output. Okay, you should execute and see this particular code by yourself in your computer. So here, so passing immutable data, this was our code. Here this n is an what? It is an integer and it is carried, it is copied to the variable a. Since it is immutable, so the changes are not reflected back to the original function, and this is the what? This is the output. So next we will go to passing mutable data. So what happens in this case? If a variable is referring to a mutable type, then any change in the value of mutable type will not change the memory address of the variable. So in the previous case, the memory address was changing. Why? Because we have passed an immutable data type. But in this case, the memory address will not change because we have passed a mutable data type. So let's try to understand it with the help of a code. There are two cases of mutable data. This is the first case of mutable data. So this is the code. Let me explain you this code. Okay, so this is the case 1 of passing mutable type value to functions. Okay, so what is the name of the function? The name of the function is test mutable. Okay, so here what is the first line which will be executed? The first line that will be executed is this line, the line number 8. So what is there in line number 8? So what is the data type? Can you say me? This data type is a list. Why it is a list? Because we have enclosed it in this particular bracket. So let's try to understand this program. So we have created a list in the variable. What? The variable is y. So let's say this is the output screen. What will be displayed? The first line will be list before function call y. So what will be displayed here? 1, because 1 is y, in y what is stored? 1 is stored. After that, the test mutable function is being called. That means line number 10 is being called. So in line number 10, the list which is stored in the variable y, it will be copied to the variable x. But now you should remember one thing, that let's say the memory address of y is 100. So y is what? It is a mutable data type because it is a list, and the memory address of x will also be how much? The memory address of x will also be 100, because I already said that if it is referring to a mutable data type, then the memory address will not change. Okay, so what is stored in y? 1 is stored in y. So what is stored in x? 1 is stored in x, because y is copied to x without changing the memory address. So what will be the second line of output? Inside call function now. So it will be inside call function now. After that, what will be the next line? The next line will be, due to lack of space I am writing here, list received and x. So what is stored in x? You can see here 1, so the output will be 1. Next line, after that, see, x0 equals to x0 plus 1. Now what is this 0? I have already discussed in class 11 that 0, it is the index starts from 0. So here we have only one element, and what will be the index of that element? So if this is the list, the index of this element is 0. So here what we are doing, x0 equals to x0 plus 2 means, what is x0? x0 means 1, because in the index 0, what is the value? The value is 1. So 1 plus 2 will get how much? 3. That means in x0, now what is stored? Now 3 is stored. That means this 1 will be replaced by 3. Why it is replaceable? It is replaceable because it is a mutable data type. Okay, so this replacement is happening in which variable? It is happening in the variable what? It is happening in the variable x, but the memory address of x and the memory address of y is same. So since both are pointing to the same memory address, therefore this y will also be changed to 3. Have you got it? After that, what will be the next line which will come in the output screen? The next line is this line, list within call function after changes x. So what will be displayed now? Is it 1 or 3? It is obviously 3, because list is a mutable type and we have changed the value from 1 to 3. In which line the value has been changed? The value has been changed in line number 6. After that, the control will come to the line number 11. So what will be displayed in the final line? In the final line, list after function call y. So since the memory address of x and y, these both are same, therefore what will be displayed here? 1 or 3? Here of course not 1, here 3 will be displayed. Okay, this is in contrast to the previous example which we discussed. There the changes were not reflected into the original function, but here the changes are reflected to the original function. Let's see the output a little bit clearly. Okay, so this is the output which we will get after running the above code. Okay, I hope it is clear. So this is the case 1 of mutable data type. Let's run and show you this particular code. So this is the code, and if we run it, we'll get the output which I have already explained to you. You should execute this code and see it for yourself. Okay, so next, so here this was our code. Here the function calling is happening and we are passing a mutable type. So here list, it is a mutable data type. So hence no change in memory address. As I have already explained, the memory address of y and x will be same in this case. So we'll get this as the output. I hope it is clear. So what can be said, concluded? Changes, if any, in mutable types are reflected in the caller function if its name is not assigned a different variable or data type. So here we have copied x to the variable a, but we have not assigned a to a different variable. Therefore, the changes are reflected to the caller function. That means the changes are reflected in the main function. That means we have changed from 1 to 3, and that change is reflected in the main function also. Okay, so let's go to the case 2. So what does case 2 says? See here, so this is the code for case 2. We'll discuss case 2. I'll explain it to you properly. So this is the case 2 of mutable data type itself. So let's see how this program will run. So at first, obviously, line number 10 will be executed. So here we have created a list. What is stored in the list? 1, 5. So what will be the index of 1? The index of 1 will be 0. What will be the index of 5? The index of 5 will be 1. After that, what will be the first line of output? The first line of output will be list before function call, y. So what will be displayed as the first line of output? 1, 5. Okay, I hope it is clear. It's very simple. We have created a list y and we have stored 2 elements in the list which are 1 and 5. So the first line we have just directly displayed y, so it will be displayed as 1, 5. After that, the function calling is happening in line number 12. So let's say the memory address of y is 100, since it is a mutable data type. So this y will be copied to x, and what will be the memory address of x? The memory address of x will also be the same as y. That means the memory address of x will be nothing but 100 itself. Okay, so after that, what will be the next line of output? The next line will be inside called function now. So only this line will be displayed. After that, here I have used /t. So I think you know the meaning of /t. /t means horizontally it will leave certain spaces. Okay, after that, what will come in the next line? List received comma x. Very simple. What is stored in x? Whatever was stored in y, it is only stored in x. Therefore, what will be displayed now? 1 comma 5. After that, the main case 2 will start now. Please pay attention here. So in the 6th line, what we have done, we have created a new variable. The name of that variable is new itself. And there, what we have given, we have taken a list. The contents are 7 comma 3. So now new is a different variable, so it will not have the memory address 100. It will have the memory address, let's say a different memory address. Let's say the memory address is how much? The memory address is 200. After that, pay attention to the 7th line. The 7th line is the line which makes all the difference. Here x equals to new. That means whatever is stored in new, it will be stored in x. So what is stored in new? 7 comma 3. Now, so what will be stored in x? In x also, now 1 comma 5 will not be stored. Now, since new has been assigned to x, therefore now in x also, instead of 1 comma 5 as previously, now what will be stored in x? 7 comma 3 will be stored in x. Also, the now x will not point to the memory location 100. Okay, now the memory address of x will also change to the memory address of new. What was the memory address of new? It was 200, 200, 100. These are just fictional values. Okay, this is not the accurate memory address. I have just taken a fictional value. You need not remember this memory addresses also. So now what will be the memory address of x? The memory address of x will not be 100. Rather, the memory address of x will now change to how much? 200, because we have assigned it a different variable which is new. After that, what we have done, x dot append 8. In class 11, you already got about the append function. What append function does? With the help of append function, we can add certain more elements to the already existing list. The new elements will be added to the end of the list. So what is the current content of the list stored in x? It is 7 comma 3 after modification, after the 7th line. So now 8 has been appended. So the final list of x will not be 7 comma 3, it will be 7 comma 3 comma 8. So what will be the next line of output? Here /t has been used, so it will be it will leave some horizontal space, and what will be displayed here? List within called function after changes comma x. So what will be displayed? 7 comma 3 comma 8. It will be displayed in the output screen. After that, see, the control will come back to the 13th line. Here what will be displayed? List after function call comma y. See, the memory address of y was 100, but the memory address of x has been changed to 200. So what will be displayed here? 7 comma 3 comma 8 or 1 comma 5? Of course 1 comma 5 will be displayed. Okay, so you may ask that it is a mutable data type, so why the changes are not reflected? The changes are not reflected because even though it is a mutable data type, we have assigned it to a different variable in the middle of the function. So this is the case 2. So if a mutable data type is assigned a different variable, then the changes are not reflected back to the calling function. So why the changes are not reflected back to the calling functions? It is so because the memory address itself changes. Okay, so if we see the output, so this will be the final output. Okay, I hope you have understood the output. Let's run and see this particular program. Okay, so this is our program of case 2. So this is our output. See here, this line list within call function after changes, this line is within the function definition itself, but since the memory address has been changed because of assignment of a new variable, therefore the changes are not reflected back to the calling function. Okay, I hope it is clear. Now let's go back to the slide. Okay, so here we have passed immutable type. Okay, so but here the main change has happened in the 7th line, but list is a mutable type, but it is assigned a different variable, hence the changes are not reflected back to the calling function, as I have already explained in the last few minutes. Okay, and this is the output. So what can be concluded? We can conclude that changes, if any, in mutable types are not reflected in caller function if its name is assigned a different variable or data type. So if we assign its name a different variable or data type, then the changes are not reflected back to the main function. Okay, I hope these concepts are clear. I'll see you again. Thank you very much.